3.3 Phase changes. A large iceberg contains enough fresh water to supply millions of people with water for a year. As it moves into warmer areas, the ice changes to liquid water and eventually disappears. What happens when a substance changes from one phase to another? Characteristics of phase changes. What are 6 common phase changes? Characteristics of phase changes. When at least 2 states of the same substance are present, scientists describe each different state as a phase. A phase change is the reversible physical change that occurs when a substance changes from one state of matter to another. Melting, freezing, vaporization, condensation, sublimation, and deposition are 6 common phase changes. This diagram lists 6 physical changes that can occur among the solid, liquid, and gaseous phases of a substance. Each arrow in the diagram represents a different phase change. All phase changes share certain characteristics related to energy and temperature. What happens to a substance's temperature and a system's energy during a phase change? One way to recognize a phase change is by measuring the temperature of a substance as it's heated or cooled. The temperature of a substance does not change during a phase change. This is a graph of the data collected when a solid piece of naphthalene is slowly heated. The temperature of the naphthalene rises until it reaches 80 degrees Celsius. The temperature remains at 80 degrees Celsius, the melting point of naphthalene, until melting is complete. If liquid naphthalene is cooled, its temperature will drop until it reaches 80 degrees Celsius. It will remain at 80 degrees Celsius until all the liquid freezes. The temperature at which a substance freezes, its freezing point, is identical to the temperature at which it melts. If liquid naphthalene is heated, its temperature keeps rising until it reaches 218 degrees Celsius, the boiling point of naphthalene. Until boiling is complete, the temperature remains at 218 degrees Celsius. During a phase change, energy is transferred between a substance and its surroundings. The direction of the transfer depends on the type of phase change. Energy is either absorbed or released during the phase change. The ice sculpture of a dog sled was carved at a winter fair in Fairbanks, Alaska. The ice sculpture will start to melt if the temperature rises above 0 degrees Celsius or sunlight shines directly on the ice. During an endothermic change, the system absorbs energy from its surroundings. Melting is an example of an endothermic change. 1 gram of ice absorbs 334 joules of energy as it melts. This amount of energy is the heat of fusion for water. The heat of fusion varies from substance to substance. Energy released as ice forms on these strawberry plants keeps the plants from freezing at temperatures slightly below 0 degrees Celsius. 1 gram of water releases 334 joules of energy to its surroundings as it freezes, the same amount of energy that is absorbed when 1 gram of ice melts. As water freezes, it releases heat. The flow of heat slows the drop in temperature and helps protect the crops from damage. During an exothermic change, the system releases energy to its surroundings. Freezing is an example of an exothermic change. How does the arrangement of water molecules change during melting and freezing? The arrangement of molecules in water become less orderly as water melts and more orderly as water freezes. Melting. Each water molecule contains 2 hydrogen atoms and 1 oxygen atom. In ice, attractions between water molecules keep the molecules in fixed positions. Any energy gained by the water after a phase change increases the average kinetic energy of the molecules, and the temperature rises. When ice cubes are removed from a freezer, heat flows from the air to the ice. As the ice gains energy, the molecules vibrate more quickly. At the melting point of water, 0 degrees Celsius, some molecules gain enough energy to overcome the attractions and move from their fixed positions. When all the molecules have enough energy to move, melting is complete. Freezing. Often people think of cold temperatures when they hear the term freezing, but substances that are solids at room temperature can freeze at temperatures that are quite high. For example, silicon freezes at 1,412 degrees Celsius or 2,574 degrees Fahrenheit. Any energy removed after the freezing is complete decreases the average kinetic energy of the molecules, and the temperature drops. When liquid water is placed in a freezer, energy flows from the water to the air in the freezer, and the water cools. As the average kinetic energy of its molecules decreases, they move more slowly. At the freezing point of water, some molecules move slowly enough for the attractions between molecules to have an effect. When all the molecules have been drawn into an orderly arrangement, freezing is complete. Vaporization and condensation. The phase change in which a substance changes from a liquid into a gas is vaporization. Vaporization is an endothermic process. 1 gram of water gains 2,261 joules of energy when it vaporizes. This amount of energy is the heat of vaporization for water. The heat of vaporization varies from substance to substance. In a refrigerator, phase changes keep the food cold. Energy from inside the food compartment is used to change a liquid to a gas in the evaporator. Energy is released when the compressed gas changes back to a liquid in the condenser. During these phase changes, energy flows from the inside of the refrigerator to the outside. In a refrigerator, a pair of phase changes keeps the food cold, such as this diagram here. Evaporation. After a rain shower on a sunny warm day, you may notice puddles of water. After a few hours, the puddles may be gone due to evaporation. Evaporation changes a substance from a liquid to a gas at temperatures below the substance's boiling point. Evaporation takes place at the surface of a liquid and occurs at temperatures below the boiling point. The water level in the bird bath decreases over time. Some molecules near the surface are moving fast enough to escape the liquid and become water vapor. The greater the surface area of the container, the faster the water evaporates. When water evaporates in a closed container, water vapor collects above the liquid. The pressure caused by the collisions of this vapor and the walls of the container is called vapor pressure. The vapor pressure of water increases as the temperature increases. At higher temperatures, more water molecules have enough kinetic energy to overcome the attractions of other molecules in the liquid. Boiling. How are evaporation and boiling different? As you heat a pot of water, both the temperature and the vapor pressure of the water increase. At 100 degrees Celsius, some molecules below the surface of the liquid have enough kinetic energy to overcome the attraction of neighboring molecules. Because water vapor is less dense than liquid water, the bubbles quickly rise to the surface. When the vapor pressure becomes equal to atmospheric pressure, the water boils. The temperature at which water boils is the boiling point of water. Boiling takes place throughout a liquid. The boiling point of a substance depends on the atmospheric pressure. The normal boiling point of water at sea level is 100 degrees Celsius. At higher elevations, the atmospheric pressure is lower, so the boiling point is lower than 100 degrees Celsius. Condensation. Condensation is a phase change in which a substance changes from a gas or vapor to a liquid. Condensation is an exothermic process. Condensation is responsible for morning dew and the fog that forms on a mirror when you take a shower. Where does the name dry ice come from? Dry ice is the common name for the solid form of carbon dioxide. Solid carbon dioxide does not form a liquid, as its temperature rises. At room temperature, dry ice can directly change from a solid to a colorless gas. Sublimation is the phase change in which a substance changes from a solid to a gas, or a vapor, without changing to a liquid first. Sublimation is an endothermic change. As dry ice sublimes, the cold carbon dioxide vapor causes water vapor in the air to condense and form clouds. This technician is hanging a mosquito trap. The trap is baited with dry ice because mosquitoes are attracted to carbon dioxide. When a gas or vapor changes directly into a solid without first changing to a liquid, the phase change is called deposition. This exothermic phase change is the reverse of sublimation. Deposition causes frost to form on windows. When water vapor in the air comes in contact with cold window glass, water vapor loses enough kinetic energy to change directly from a gas to a solid. Thank you for listening to section 3.3.